If you find yourself stopping at the gas station more often than usual, your vehicle may be trying to tell you something. Poor fuel economy can be caused by several different issues, but one of the most common is failing upstream oxygen sensor. When the oxygen is not reading correctly, it can send inaccurate information to the engine computer. That can cause the engine to run richer than normal, use more fuel than necessary. In this case, I believe that is exactly what's happening with my vehicle. Even though the downstream sensor is not directly responsible for maintaining the air-fuel ratio, it can still have some effect, and replacing it may also help clear the jet engine light. I actually bought this replacement sensor quite a while ago, and it has been sitting on the shelf ever since. But today, it finally has a purpose. Now the main question is whether this sensor is truly correct match for the faulty one currently installed in my car. Even though this replacement sensor does not have the original connector attached and only comes with bare wires, the wire colors are identical. There is one gray wire, one black wire, and two white wires, exactly the same as the old sensor in the vehicle. This is a good sign, but before installing it, I still wanted to make sure it was the right sensor for the job. I checked the heater circuit and tested the signal wires, and the readings matched the original sensor. When an upstream oxygen sensor fails, it can quietly reduce fuel economy and slowly drain your wallet. I have already captured the upstream sensor signals on DSO, and you can find that link in the description below. So in this video, we are going to install this sensor and see if this replacement can solve at least part of the problem. The moment of truth is now, and this is the sensor, the oxygen sensor, sensor 2, after the catalyst converter. But what we need now is, first of all, the old one inside the car should be removed, cleaned, and put it back and see if that solves the problem. If not, then we have to replace with the new one. So stay tuned. I'm cleaning the sensor to see whether that helps. Then we will reinstall it and check if the sensor starts working properly again. If it still doesn't improve, the only option left will be to replace the sensor. Since cleaning and reinstalling the sensor didn't solve the problem, I need to replace it with a new one. However, I have to reuse the old connector so that it matches the car's wiring harness. Right now we are trying to connect each wire to the corresponding wire, which has the same color. Black to black, white to white, and gray to gray. We're gonna heat shrink it with heat shrink tubes. So this scotch is just to make it that it becomes very durable. Now this is the sensor that we have taken out of the car, and it has got its days on it, as you see. Here I'm going to install the new sensor, which I connected the original connector. After we're done, we are going to diagnose and see if the code is there. After I installed the new sensor, the check engine light went off by itself before I cleaned anything. However, the fault code was still stored in the engine computer, so I erased it manually. After cleaning it, there was no DTCs returned.